For our last absolute value example, we're going to look at a strange one. Here's where we have an absolute value expression not set equal to a constant like it often is, but set equal to another absolute value expression, and we're having to solve for x. So like this example, we have the absolute value of 2x plus 2 set equal to the absolute value of x minus 1, and we want the x that makes these match up. So we'll come back and work this one in just a second, but before we do that, let's talk about this in kind of an abstract sense and see like what needs to happen. Well, ideally, a great thing that could happen would be if a was equal to b. If you have the absolute value of something a equal to the absolute value of something else, we'll call that b. It would be ideal if a equals b, and then like here we could set 2x plus 2 equal to x minus 1 and figure out what x's would make those match up. That seems very natural. But in addition to that, you could also have a equaling negative b, and the reason for that is if a was equal to negative b, well then the absolute value of negative b would obviously be the same thing as the absolute value of b, right? Because they would have the same distance away from 0. So this would work. And one other thing you could say, and actually let me erase this real quick. Okay, so one other thing you could say would be that negative a is equal to b for the same reason. So really this kind of yields 3 equations here, but actually if you look closely, the last 2 are actually saying the same thing, because if you take this example here, if you divide or multiply by negative 1, then what does that give us? Well, it gives us negative a equals negative b divided by negative 1 is b. So really these 2 are saying the same thing, so we actually don't need to write both of these. So if I erase this and just keep the first 2, this is in effect what we have to do in a practical sense. If you have the absolute value of one thing set equal to the other, then basically what it boils down to is setting a equal to b, and if they match, then you could solve that to get whatever answer for x that you need. Or a can be negative b, which between me and you, that's actually the same thing as b being negative a as well. So we can solve both of these, and that'll lead us to our answers. Okay, so for this example, we're going to do 2 things. I'll do them in different colors. So on the one hand, you could have 2x plus 2 equal to x minus 1. If those match, then the absolute values of those things would be equal. Or you could have 2x plus 2 equal to negative quantity x minus 1. Now the thing that's nice about these 2 equations is they don't have absolute values, and we can solve them as we typically would. So for this equation, we know the drill. We put the x's on one side and the constants on the other. So if you subtracted x from both sides, then you would get x plus 2 equals negative 1, or you'd get x equals negative 3 if you subtracted the 2 to the right. So there's one solution. And then let's solve this one as well. We'd have 2x plus 2 equal to negative x plus 1 like that. And then let's add x to the left and get 3x, and let's subtract 2 to the right and get negative 1, and we get x equals negative 1/3. So we get 2 solutions here, and so this is how you handle this unusual situation. You set the 2 expressions inside the absolute values equal to each other, and one equal to the negative of the other, because the absolute values are going to make that a moot point, having a negative attached to one of these guys. And so when you have these equations that don't have absolute values, you solve those like normal and get your final answer.